Hi guys and girls on YouTube, and welcome to my channel. In this video we're going to be looking at this 14-inch JVC CRTV. Now this is quite a significant TV. I think it's dating from about the late 1990s, and I say quite significant because if you were repairing TVs in the late 1990s, you'd have almost certainly come across this fault. Possibly not on this TV itself, because this TV, although it says JVC on the front, it was actually produced by a company called Onwa, and you could get exactly the same TV with lots and lots of different names on the front. So it's just a badged up cheap TV wearing the JVC badge. Now the problem was it concerned the power supply. Capacitor used to drive up. I've got a feeling it was in the power supply next to a hot running resistor, and I think what happened was, as the power supply dried up, the conduction time of the chopper transistor was far too long, and what it caused a massive rise of EHT. You could get like the EHT peaking at 40 kV, and you'd turn the TV on, there'd be a massive rise of EHT, there'd be a crack and a bang as the set blew up. And then you'd need extensive repairs. Now, as far as I can remember, there was no circuit diagram for this TV. It was a relatively easy thing to fix, and at one time I think quite a few manufacturers actually produced a repair kit. It was quite easy, straightforward, but you needed quite a few components. It did cause a lot of damage. And at the time there was a man called Steve Beechin who used to write for Television Magazine. And by the way, Steve, if you're watching my channel, because I know you've occasionally watched my channel, you are my hero. I used to read all your articles in Television Magazine. And Steve, he actually produced a service manual for this TV. And I think JVC did an investigation into the problem. And it turned out to be there was a safety circuit that didn't operate. I think it turned out to be some fault with the safety circuit, and they got the component values, they calculated something wrong, and what happened is, as the secondary of the power supply started to rise, there was a circuit over voltage protection, and that should have switched the set off, but it never ever operated. And in some TVs they call it X-ray protection, because obviously when you rise the EHT potential to the CRT, it generates X-rays. So in some manuals it'll be referred to as X-ray protection, but in this set it never actually operated. It just blew up the telly when the capacitor dried up. Now on the back of this telly there was a PAT test, and I think the last test was 2009, so it's pretty safe to assume that this set's not been used since 2009, which would probably give it about 10 years of use, would it? So there's every chance that this set has already been modified, or the capacitor's already been changed. But what I'm not going to do, I'm not going to plug this in until we take the back off and we change the capacitor and the power supply. So what I'm going to do now is I'm going to stop the camera. I'll dig out the service manual that was produced by Steve Beechin, because I can't remember all the different faults it used to cause when it blew up. There was a lot more damage than just the power supply. So I'm going to stop the camera a minute and I'll look for the manual. Right, so I've managed to find the service manual produced by Steve Beechin. Let's have a look what model we've got. It's a C-14ET1EK. CT14E. Oh, that one there. But if you look at this, these are all the different sets that use the same chassis. You've got the Akai, you've got the Hinari, Matsui used it 3 times, you've got Goodman's, and you've got all these different, probably about 15 there, Albro, Bush models. Actually, it's got the date on there, 1995-96. I wasn't far off, was I, with the late 90s. Right, let's just turn over to the first page. Right, it says here, yes, C911 produce a HT rise from 112 up to nearly 300 volts, so it's no wonder that the set blew up. Right, it's actually detailing here why the safety circuit didn't switch the set off. It tells you there that a modification kit was produced by Charles Hyde. Well, I never actually bought these kits, I just bought all the parts separately. Scroll down so you can look, and then the first thing we need to do is find the diagram of the power supply. Right, so that's the circuit diagram, the power supply for the 14-inch. It's a very basic discrete component, self-oscillating power supply. And the capacitor, that is the one that used to cause the problem in the base drive to the chopper transistor. So we need to change that before we even turn this set on. I mean, it's quite possible it's already been changed, or it's been repaired in the past. So that's the first thing to do, and then we need to find where the overvolts protection circuit is and carry out this modification that's detailed on this front page. Right, so let's just have a quick look in the back first. Now, the first thing I've noticed, rusty screws. That's not a good sign. This has either been stood somewhere very damp, but we've got a screw here that won't come undone, so I'm going to have to play around with that for a minute. Right, so the bad news is this set has been somewhere very, very damp, or it's been sitting outside in the rain. I very, very much doubt this is even going to work at all. But we can have a look at it anyway. Even if we don't get round to plugging it in, we can have a good look. But you can see how much rust and corrosion's on there. This has been very wet. Now, chip on there says Teletext, so of course this is a Teletext version of it. Now, this set has already been repaired, so it will have blown up in the past. The quality of the work is very, very poor, so this is not something I've done in the past. But we can get the chassis out, we can have a good look at it, and I'll show you where the problem originally came from. And then we'll look up in the circuit diagram what the problem was with the protection circuit, why it never operated. But once I pull the chassis out, you can see why this failed so quickly. Right, so here is the switch mode power supply transformer. So the power supply sections here, that's the set the set HT controller. But straight away you can see what the problem is. You've got two capacitors here, and that one is almost touching on this great big wire wound resistor, which will no doubt be dissipating a lot of power, and that is the reason that these capacitors, they dried out so quickly. Very, very poor design. Now, if we look down here, there's lots and lots of corrosion. I'm still in two minds whether to dry it out and turn it on, see what happens. But let's just have a look. This has been repaired, so let's just have a look where the repairs have been. So if you look down there, I'll zoom the camera in, you can see that a diode, somebody's cut it there to test it and then resoldered it back instead of removing it from the board. You've got down there two safety resistors just twisted together to make the right value instead of putting the right one in. Just there's another diode that's been just cut out the board, obviously tested, and it was, well, I would imagine it's been replaced because they've cut both ends of the diode, if you see. You know, I don't know why you do that. You just unsolder it from the back of the board rather than do that. And also, if we move around here, there's a great load of resistors strung together there to make the right value. Again, I don't know why you do that. Why wouldn't you just put the right one in to start with? And as you can see, that one there is not a wire wound like these, so it's got very, very hot. So this has, in the past, almost certainly had a major fault, and it's probably the fault with them capacitors there. Now what I'm going to do, I'm going to take a quick look at the underside of the board. And the underneath of the board has made my mind up. We're not going to be plugging this in. Look at the state it's in underneath. This has been very, very wet somewhere. So we're definitely not going to be plugging this telly in. But it will, of course, supply 1 or 2 parts as a donor if we ever get another one in. The line transformer might be alright, the tube might be alright, the scan coils might be alright. But if you look in the power supply there, you can see that these transistors have been desoldered and resoldered back in. You can see all the parts been changed. The chopper transformer, that's all been resoldered. So it has had quite a bit of extensive repair in the past. And in fact, if you desolder a transistor from the back, why would you not desolder the diodes from the back? Why cut them from the top? It doesn't make sense really. But anyway, so we're definitely not going to be plugging this telly in. Yeah, there's them 3 transistors there. In fact, somebody's changed them because they're actually BC 640 and that's a BC 3 something. You wouldn't find BC transistors in a Japanese telly. So these capacitors will have been changed. But I mean, how ridiculous. Whoever's changed them is put them back in the same place they would have been in the first place. What you should have done is bent them right over, or bent that resistor over like that, and bend the capacitor this way so they're not in contact with each other. But whoever's done that has just left them like they were originally when the set came out of the factory. But I mean, there's plenty of good spare parts in here. There's a microprocessor, an EEPROM. It would seem all the bits at the front of the set are alright. It's the back that's got very wet. That's the line transistor. That's still the original one there, look. Right, so I've read the technical description for the protection circuit and you can see how it operates. The HT rail is monitored there, and when it goes above 9.1 volts, that Zener conducts, it turns that transistor on, and that should pull down the base of that transistor to put the set into the standby. But when this transistor is fully saturated, it cannot pull the base down low enough because of that 680 ohm resistor there. So even when this operates and that transistor's turned on, this one remains turned on, it doesn't turn off. And the recommended modification was to short out that 680k resist 680 ohm resistor there, so when that turns on, it pulls that base straight down to ground potential to make sure the transistor's off. And it also says that that 10k in the base there was replaced by a 47k. But that is the reason why the protection circuit never operated, because there's a resistor in there when you don't need it. Anyway, that's it. We've come to the end of the video. It's a shame we can't power this setup, but I think the state it's in, it would be a really stupid thing to do, and we could end up causing more damage to something that could be a good parts donor. because you never know, I might come across another one of these. So anyway, many thanks for watching. I hope you've enjoyed the video. I'll catch you in the next one. Goodbye. Right, now, I bet you thought that was the end of the video, but look what I've got here, another identical set. Now, the first one I looked at, that's been on my computer for about 6 months or so. That's an old video I've not got around to putting on YouTube yet. But in the meantime, I've come across another identical one. So let's turn this round. It's exactly the same model, C-14ET1EK. Let's get the back off this and have a look inside it, because now whatever's wrong with this, we should be able to repair it with the scrap one, whatever fault it's got. So let's get the back off and have a look inside this one first. Right, so that is in a lot better condition. It's not mint by any means. We do have some rust on here, and it looks like it's been standing for a while. But it certainly doesn't look like it's been out in the rain like the other one did. Now if we come round here, the first thing you'll notice is the two capacitors that give trouble. I'll zoom in. Somebody's already replaced them with they look like Panasonic 105 degree types. So I don't think it'll be necessary to change them again. Right, zoom the camera back out. So I think the first thing we're going to do with this is give it a good clean out. I can see I've already checked the scan coil rubbers. They're nice and soft, so they're no cause of concern. The actual tube, well, I've never even heard of that brand, so it looks like that might be just a cheap one. But I can see the odd spot of electrically conductive glue. There's a bit there and there's some more there. That will need removing before we plug it in. But let's just have a look what the underside's like, because obviously if them caps have been changed, the chances are it's had more work done to it as well. So let's have a look underneath first. Well, you can see we've got SCART socket on there. So right, let's tip it up then. Actually, just one more thing before I tip it up. I don't know what this does, but if you see there where the speaker's plugged in on that 2-pin connector, I'll just unplug it. There's another identical connector there that would plug into. I can't remember what that is off the top of my head, but we're going to have to make a note of that comes off that one, and not that one which is just moved towards. So that's a bit of a rubbish design, really. So if you look there, I've just marked that plug that goes to the speaker, and I've also marked the socket there with a bit of red pen, so we can't, or we don't accidentally put it on the wrong one. Right, so the underneath's not looking too bad. Straight away I can see the SCART socket's been resoldered. That's the chopper transistor there. That's been getting very, very hot, as you can see where the board's black, and so all these joints will want resoldering. What else? The frame output IC there, somebody's already resoldered that. Now these bits of wire here are for these tracks that carry line scan current, very high peak currents. So I would imagine that them wire links there are factory fitted, so you don't get a dry joint on here and end up with a big burn up, which was quite common in some tellies. But yeah, I can see the odd dry joint here and there. Nothing really major. I'll just test that transistor to make sure it's not shorted out, and can't really see much else. There's a bit of a dry joint there. I'll just do a few dry joints and then we'll go for the switch on, see if we can get at least one of these going. Right, so I've done them dry joints. I've also give it a little bit of a clean up with some flux remover. Now somebody did ask a question in one of my videos, where do you buy this from? Well, I would imagine that you cannot buy this exact one anymore, and I'll tell you for why. I actually bought 100 tins of this, and it's a long time ago, and I'm still using it now. I bet I've got 50 tins left. And if we look on the bottom, the sell by date is 2nd, or is it 17th of the 2nd, 1993. So I wouldn't think for 1 minute you can still buy that, but this is my go-to product. I've got enough of this to last me the rest of my life. Right, so we'll just wait for that to dry out, and then I'll remove that glue on the back, and maybe just run a little bit of power through the main reservoir capacitor, and then we'll power it up, see what happens. Right, so I'm just reforming the main reservoir capacitor. I've come back to it a bit later on. That's ready. There's no reason now why we can't just plug this in and see what happens. I would imagine it works, but let's get the chassis back in and see. Right, so I've just put the camera down a minute. Let's just lift it up a little tiny bit more. No, a bit more yet. There we go. Because I can't just, because the back's not on, if I push the on and off switch, it'll just push the chassis back. So what I'm going to have to do is hold the chassis with a screwdriver and then turn it on. So here we go. Yeah, it's off. 3, 2, 1. And nothing's happened. It's completely dead. So there is actually something wrong with it after all. Right, let's just check there's a fuse in the plug first. Right, so it's actually the power supply that's not running. There's no secondary voltages been produced, but I do have 330 volts across the main reservoir capacitor. So the question is, can I still find the circuit diagram? Because it's about 6 months since I last did this, and I really don't know where I've put the diagram now, so I'm going to have to stop the camera and come back to this in a minute. That's if I can find the diagram. Oh, tell you what, let's just have a quick look round. No, I'll tell you what, let me see if I can find the circuit first. Well, that turned out to be a good move looking for it, because I'd lost about 12 months ago my Thorn 1500 circuit diagram, which has got shoved in there by mistake. So that's my diagram for the 1500. That's good, because I've got a 1500 video to make, but I've had to put that in hold because I couldn't find the circuit diagram. But anyway, so back to this. We need to look at the power supply section. Right, so it's a self-oscillating power supply. So what we need to get it going is a startup pulse, and that will be provided by this high value resistor here, which is connected to the positive of the reservoir capacitor, and that provides a pulse to the base of the chopper transistor to get it started. Now once it's started, it will run for an auxiliary winding on that transformer. So there's two things that's going to stop this power supply from working. Either that is open circuit, or we have a short on the secondary. Either one of them two diodes might be short circuit. So I'll just check the diodes first, because that's the easiest thing to test in circuit. The resistor, with it being a high value, might have to remove it from the circuit to test it. Right, so this is the easiest thing to check, because we've only got two secondary rails of 17 and the HT rail, which is probably 115, 120 volt. Now both them diodes actually check out alright. That's D402 across there, that's D401. So the next suspect is going to be resistor R913. And it's there, R913. Now you can see by the blackening of the board, this is a very hot running area, and that will be highly suspect, but we're going to have to desolder it first to check it out of circuit. 913 there. Right, so if you look there, I've just desoldered one end so we can test it without it touching that pad. Now you can't do that with surface mount, can you? We didn't know how we were lucky. We didn't know how lucky we were in these days with through-hole components. Now it actually tests 226k. The service manual says 220, so I would imagine that's well in tolerance. That's not the problem. Right, so looking at this diagram here, the auxiliary winding is actually pin 12 on the chopper transformer through that diode, and that is to that reservoir capacitor there. Now that provides the supply to run this circuit when this resistor has actually started it up. Now it does appear that diode D903 is open circuit. I measured it. I've measured it a couple of times and it appears to be open circuit, and then I measured it again and it appears to work, but I've tried it again now and it appears open circuit again, so it could be intermittent. So what we're going to do is change that, and it is there from pin 12 D903. Now sometimes with diodes, when they're faulty, when you actually heat this up, the diode might recover and it may appear to work again, but it certainly doesn't seem to test alright at the moment. So let's just get it out. Yeah, I don't like that diode one bit. On my fluke meter it appears to have a normal junction voltage, but when I try it on my Onwa, it has a different ohms reading than you'd expect for a good diode. Now it says on there BA157. The diagram says it's a BYT52J. I've probably got either of them, but let's put in a BA157. Let's put in the same one that came out. Right, so I haven't got a BA157, I've only got a BA159. So the BA157 is, where we go here, 400 volt, and the BA159 is exactly the same diode but 1000 volt. In fact, if you look up there, my equivalent book BA157 and go across, the replacement equivalent BA159. So let's put the BA159 in. Now I'm getting a bit short of them because these are donkey's years old. Look at that, see me, small elephants, large elephants, and I'm just down to the last two. Let's get one of them in. Right, now this is interesting. The fluke meter says this diode's alright. My Onwa analog meter tells me that the diode is not alright. Now the reason for that is your terminal voltage here in your fluke, whereas on the terminal voltage on the analog meter you've got about 3 volts because it's 2 batteries, and that 3 volts can upset a faulty diode junction, whereas the terminal voltage on here doesn't. So using this is not a very good test, but I'll tell you what I think it is. I think this has been stressed in manufacture, it's not been correctly bent, and I've seen this quite a lot. I first saw it in the 90s with a diode, where there was a particular TV and every single diode in the TV was faulty, and they go intermittent, and it's because these aren't bent with a 90-degree bend holding the lead out. So if you look at that, if we actually press the diode, can you see that the reading there, it's got an open circuit when you press your finger on it. Now we've got a higher junction voltage than what we should be. It should be 0.5, 0.6. There, press the diode, it's alright now. Now it's gone open circuit, so that diode is definitely faulty. Right, so my tip of the day is with diode semiconductors. When you're fitting these, take a pair of pliers and actually hold the diode like that, and then bend your leg to a 90-degree, and then it makes sure that you're not actually stressing the junction inside the encapsulation. Don't just bend it with your fingers, because that's where the trouble starts. So let's do, I'll have to put the camera down to show this, but let's do that next. And there we go. That's what it's like when you bend it with a pair of pliers. Right, let's get that fitted back into here and see what happens. Right, so that's it, the diode's fitted. Now I've lost my yellow pair of Lindstrom cutters, so I'm going to have to use these box end cutters. Look at that, perfectly fitted. Right, let's plug it in again, see what happens. Right, now it's such a long time since I repaired one of these, I can't remember whether it comes on in standby and you have to press a button on here or you need the remote. But if you look at that, the HT rail actually goes to a relay. So the first thing that'll come up is a 17 volt, so it might just put a red light on there, or it might come on, I cannot remember. But I'm going to flick it on here. Right, 3, 2, 1. Aha! We have a red light, and I heard a relay click. Now, does that mean it's on? Because we've no picture. Or do we have to press a button? I can't remember. Let's press them all and see what happens. No. Oh, do you press that again? Nope. We still have a red light. But anyway, the power supply is up and running now. I just need to figure a way of getting this on. Or do we need the remote control? Stop the camera while I think about this. Oh, I know the picture's on. There we go, it's lit up. Why didn't I see that before? Right, let's get it back in its case. I'll just check the voltage on the HT rail, see what it is. I would think between 115 and 120 for a small set. And if that's okay, we'll get it back in the case and get a signal to it. Right, so there we go. HT rail 112.5. That seems about okay. Yeah, I've just realised now why it didn't come on. If you look at the on and off switch, there's a pair of momentarily contacts there. So if we just switched it on with this switch, it would have come on. If you switch it on just at the main socket, because these contacts aren't operated, it comes on in standby. So we don't need to press a button or the remote control, we just press the actual on and off switch on the telly. That brings it on. Right, so it's connected to the satellite box over there. Let's just put the camera down, because I'll have to hold the back of the chassis with my finger so it doesn't push out. And I can pick the camera up now. What channel's it on there? Oh, it must come on the last channel it was used on, which would be 4. That's what it came on, into number 4. Just see if there's any channels tuned. There we go. Number 1 is tuned into Skybox, right. Let me put that down again. I'll just get a channel on Sky. Oh, picture looks really sharp. Is that Sky News? Yeah. Oh, no signal. Why have I got no signal on Skybox? Right, that's better.
One more downhill. Okay, well, that's refreshing.
You just find that switch on the back where get it on off the colour bars.
So
there we go.
I'll look over every detail.
Just turn the volume down a bit. And the black band there, that's actually coming from the camera. I'm not actually seeing that on the telly. But yeah, that's not... It's actually quite a good picture, that. I'm very pleased with that. Yeah. TV guide. Yeah, that's really good, that. Let's zoom this out again. Bit of volume.
Why? Don't do this now. Isn't this good? You want organic exposure, right?
Right, so all that needs is that the cabinet needs a good clean up. I'll do what I used to do all them years ago. I used to wash these in the sink and clean that out with a toothbrush, make it all look nice and shiny. So there we go, guys and girls. That is the JVC C-14ET1EK from 1995, 1996. Also comes in a variety of different names. Not actually made by JVC at all. It's made by a company called Onwa, if that's how you pronounce it. So at last the result. Now just before I go, I will be posting another video on the 11th of November, about another 10 days time, which is a significant milestone for me. So if you'd like to watch that as well, I'll say many thanks for watching, and I'll catch you in the next video, guys and girls. Goodbye.